All right, here we are for the little video review going over 4.2 to 4.4. So we're going to talk about the extreme value theorem, the mean value theorem, and then we're going to talk about concavity. Those are the things that you should be prepared for. Extreme values, first derivative. Mean value theorem says that, we'll get to that, and then concavity is second derivative. So, first one. Let's zoom this in just a little bit. If f double prime is 0, then c comma f of c is a point of inflection. True. Why is that true? Well, we talked about if f double prime is 0, if f double prime is equal to 0, then we get an inflection point. Next one. If if the first derivative is 0 and the second derivative is negative, so that gives me my critical point and that gives me negative, then f of c is a local maximum. So first derivative is 0, second derivative is negative, that means it's a frown, which means I have a local maximum. So that's true by the second derivative test. Third one. Let's zoom out just a little bit so you guys can see what I wrote. If f prime of c is greater than 0, then f of c is concave up. So this one is false. Why? In order for this to be true, f double prime of c would have to be greater than 0 for it to be concave up. Last one. If f prime is increasing, then f double prime is positive. Let's just think about that for a second. If my derivative is increasing, so let's say I had a graph, let's say that's f prime. So if my slope here is increasing, if my slope is positive, then my derivative would be positive. So if the slope of the derivative is positive, then f double prime is positive. So this is true. Next up, write out the mean value theorem. In essence, we have the instantaneous, the derivative at some point is equal to the average. So we have the derivative at one point is equal to the slope between the interval. So let's apply that. Find a point C verifying the mean value theorem. So we're saying that y prime equals square root of 25 minus square root of 9 over 25 minus 9. So the derivative is 1/2 x to the negative 1/2 equals square root of 25 minus square root of 9 is 5 minus 3 over 16. So that's 2 over 16, which is 1/8. So we're gonna try and solve for x to find out what point these two are equal. So I have 1/2 x to the negative 1/2 equals 1/8. Or another way of writing this, I'm going to multiply both sides by 2. So I have 1 over x to the 1/2 equals 1/4. X to the 1/2 is the square root. So I could say the square root of x equals 4. So what number do I take the square root of? Do I get 4? So x equals 16. and then I look back. Is 16 in my interval? Yep. So that's my C value. Next up, use the second derivative test to find the local extrema for y equals x to the fifth minus 80x plus 100. So I'm going to first take my derivative. That's 5x to the fourth minus 80 plus 0. I'm going to set that equal to 0. So factor out, divide everything by 5, I get x to the fourth minus 16 equals 0. Factor that, I get x plus 2, x minus 2, x squared plus 4. So x equals negative 2, x equals 2. These give me imaginary numbers, so I ignore them. So here are my critical points. Next, I'm going to take the second derivative. I'm going to say y double prime is 20x cubed plus 0. And what I want to do is I want to use my critical points to see where they're positive or negative. So I'm going to plug in negative 2. So I have 20 times negative 8. Whatever that comes out to be, that's less than 0. That's a negative number. Because that's a negative number, that means I am concave down. Negative means a frown, so it goes down. That means at negative 2, it's a max. Likewise, if I plugged in 2, I get 20 times 8, which is greater than 0. If it's greater than 0, then it's concave up. It's a smile, which means we have a min at 2. So if we wanted to go a little bit further, I could plug negative 2 back into my original function and say that at f of negative 2, we get 228, which is a max. Likewise, I could plug in f of 2, and I would get 92, which is a min. All right, that takes care of the first side. I'll flip it over and go to the next ones. So if you're looking at these problems, that shouldn't be an equal sign, that should be a plus. That was a keystroke error. It says find the critical points and determine if the interval is increasing or decreasing using the first derivative. All right, so first derivative is negative 2x plus 7. Set that equal to 0 to find my critical points. So I have 7 equals 2x, x equals 7 halves. That's my critical point. From there, I'm going to make my number chart. So just so we're aware, that's y prime, that we're plugging these numbers back in. So if I put 7 halves right there, a number to the left of 7 halves, that's easy to do, 0. So 0 plus 7, positive or negative? Positive. Pick a number to the right of 7 halves, so let's do 10. Negative 20 plus 7, that's negative. So I'm going from increasing to decreasing. So f is increasing from everything to the left of 7 halves. So we're increasing from negative infinity to 7 halves. F is decreasing from open 7 halves to infinity. These are open because what happens at 7 halves? I stop from going increasing to decreasing. And if you wanted to actually think about this graph, just as an aside, negative x squared plus 7x plus 17 is a parabola that opens down. So it should make sense that f is decreasing up until we get to the max, and then it's decreasing past it. All right, moving on. Use the following function, which is f prime, to find the intervals where f is increasing and decreasing. So where is this increasing? If the derivative is positive, so for increasing, decreasing, we want for decreasing, we want f prime to be less than 0. For increasing, we want f prime to be greater than 0. So we look at this. Where am I negative? I'm negative from negative infinity to negative 2. So negative infinity to negative 2, union 2 to infinity. Likewise, where am I increasing? Where is this positive? From negative 2 to 0, union 0 to 2. Why am I excluding 0? Is because when I'm at 0, my function is 0. So there's increasing, there's decreasing. Sorry, let's make a little divide right there. This is increasing, that's decreasing, just for you guys. B, values of the relative extrema. So we know that when the derivative is 0, I get critical points. So my critical points are at negative 2, 0, and 2. But I need it to be changing from negative to positive or positive to negative. So my extrema are at negative 2 and 2. And in fact, I can state, if I go from negative to positive, if I'm going from decreasing to increasing to increasing gives me a min. If I'm going from increasing to decreasing, that gives me a max. If I'm at 0, this is going from so this is going from increasing to increasing. So it doesn't change there. So I don't have an extreme value at 0. So how about C? Intervals on which the function is concave up and concave down. So in order for this to be true, I want to know where, for concave up, I want to know where f double prime is positive, or where f prime is increasing. For concave down, I want to know where f double prime is negative, or where f prime is decreasing. So let's look at here for concave up. Where am I increasing? If I'm going from negative infinity all the way up to this point, let's say this point is, let's say that's negative 1.5. All the way up to this max, I'm increasing, and then I change. So from negative infinity to negative 1.5, so let's say negative 3/2, I'm increasing. Then I'm decreasing, and then at 0, I stop decreasing and I go back to increasing. So that's all the way up to here. So let's drop this down close enough to 1. So let's call that 1. So I'm increasing again from 0 to 1. So I'm concave up from 0 to 1. Where am I concave down? Well, where is my graph going down? From negative 3/2 to 0, negative 3/2 to 0, and from 1 to infinity. That's where my function is decreasing. That's where it's going down. That's where my second derivative is negative. So the last one, values of the inflection points. where does it change direction? At the first derivative's max or mins. So we already found those. At -3/2, at 0, and at 1. That's everything for problem 9. Problem 10, find the min and max of the functions with a given interval by comparing the values in the critical points and the endpoints. So this is where we go. Y prime is 6 minus 2t. Set that equal to 0. So that means 6 equals 2t, or t equals 3. We check to make sure that's on our interval. That is. So we do our xy chart. X, y. What values are going to go in there? We want 0, we want 3, we want 5. So we plug these back into our function. So if I plug in 0, I get 0. If I plug in 3, I get 18 minus 9, which is 9. If I plug in 5, I get 30 minus 25, which is 5. So it says find the min and max on this closed interval at f of 3 equals 9, gives us a max, and at f of 0 equals 0 gives us our min. I'm just looking at which one gives us the largest number, which one gives us the smallest. Likewise, we do the same for b. So we go y prime equals derivative of x is 1, derivative of sine is cosine. So then I set this equal to 0. So I have, where is cosine x -1? Well, the only answer to this is pi. If we know our unit circle, where is x -1? Pi. So now I do my chart, do my x and y values. I go 0, I go pi, I go 2 pi. I plug these into the original. So I have 0 plus 0, 0. What's pi plus 0, which is pi? What's 2 pi plus 0? 2 pi. So that one's a very straightforward one. So where's my max? When f of 2 pi equals 2 pi, we have our max. And where is the min? When f of 0 equals 0. That's my min. Hopefully this is everything that you expected to see on this. Good luck on your test tomorrow. It should be pretty straightforward.